Alright, what we want to do here is talk about displaying categorical data. So what if we have data that's given in words? So here we have a data set that's looking at eye color. And it's actually given to us in a frequency table, and just saying like how many people had blue eyes, brown eyes, green eyes, and other. But in terms of our raw data, what it would have looked like if I had sent out a survey and just said, write down your eye color, what we'd see is people would be writing down the color of their eyes. So whether it's blue, brown, maybe we had another person that's brown, and then other, green. So our actual data would be a list of words. And so within those words, 5 times, brown 13 times, green 2 times, other 3 times. So we have this categorical data, and this is how we can organize it, a way of kind of writing the possible categories that we have, as well as the frequency or the count for each of those categories. Something that's nice about this is if you add up this column here, we add this up to get our total of 23. This tells us our sample size. We talked to 23 people, and this is how the eye color is distributed. What we could do is, if we didn't want to just see the frequencies, we can look at relative frequencies, which is the idea of taking these counts here and creating percentages. So for like the percentage of blue eyes, we take 5 out of 23. And for brown eyes, 13 out of 23. For green eyes, 2 out of 23. Other 3 out of 23. And what we can do is find these percentages. So when we're finding percentages in statistics, what you want to do is type in the fraction, and you're going to get a decimal out. And the best habit to get into is rounding to 4 decimal places. That's going to give us the most accuracy. So going 0.217 and then rounding that last decimal place to 4. And then we can do that for the others as well. If we round this, 0.5652. And then we'll have a 0.08. And then for our 4th decimal place, because that all rounds up, we'll just have 3 decimal places with that 7 there. And then a 0.1304. Then once you have these decimals to 4 places, what you want to do is change it into a percentage. And remember, to change into a percentage, you want to move the decimal to the right 2 times. So we have 0.2174, thing as 21.74%. And this would be a 56.52%, 8.7%, and 13.04%. So that's how we change to percentages from fractions, and it's nice to have these relative frequencies, having these percentages, because it would be nice if we compared it to another group. Say they did the same thing collecting eye color from some other group, and we wanted to compare outcomes, like which group had more brown eyes or more blue eyes. But the percentages are nice if we take another sample and say it had a different sample size. Like say I talked to 100 people for my next sample. If we just compare the frequencies, it's going to look like the other sample has a lot more people with the eye colors, each of them, because it's just a larger sample size, so we'll have higher frequencies. But if we compare the percentages, then we can really compare which group had more blue eyes comparatively. So once we have this table, we can talk about graphing the data. And there's going to be 2 types of graphs that we make with categorical data. We're going to look at bar charts and pie charts. Bar charts are going to look pretty similar to histograms, except there are little differences that come from it being using categorical data. With our bar chart, we're going to start off with our x and y axes, just like we did with the histograms. And with our y-axis, it's actually going to be the same as for what we saw with histograms, in that this is going to contain frequency. So again, we're going to have these bars, and the height of the bars are going to be determined by these frequencies here. So for us, we need to see up to 30. So just make sure 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So we can see these different possible frequencies. And then once we have the frequencies, we can set up our x-axis. which the title of the x-axis is going to be the type of categorical variables that we have. So we're collecting eye color. Now along the x-axis, we're going to create these bins. And the bins are going to be for the different categories. So we're going to have 4 bins, one for blue, one for brown, one for green, one for other. Notice that this isn't going to be a number line. It's just going to be in words. It's like we create our bin for blue, and it's going to look like this. So notice a few things. One is that I created a little space here, and it's because we want to be a little bit off the x or the y-axis. It's because being at 0, 0 doesn't mean anything, especially if this line here isn't numerical. Then you create some width for the bin, and then you have your title there. Then we want to create a bin for brown. And something you want to do is you don't want it to start at the end of the other bin. You want a little bit of space. So we create a little bit of space, and then we create our bin for brown eyes. And then some space, and then we'll have green eyes, and then a little bit of space, and then other. So we need space between these because they're discrete bins. It doesn't mean anything to have overlap. With the histograms, the bars were touching, and it was because with a number line, you can go all the way from, say, like 9.99999, and then suddenly have 10. Here, to have it doesn't mean anything. So we want this space to make these discrete bars coming through. Then when we draw the bars, we just go to the height of the frequency. So for blue eyes, we go up to 5. Brown eyes, we go up to 13. As best we can by hand. Green, we go up to 2. Other, up to 3. Something like that. So this is our bar chart. So again, what's key is those spaces between the bins. Make sure the bins are somewhat evenly, have even widths. And then something to notice too is like when we had our histograms, we wanted to talk about shape. So we talked about symmetric, left skewed, right skewed. However, we don't want to do that here. We don't want to do that here because technically we could move these in any order. I could have written down green, blue, other, brown. As long as I had the heights matching, it would be correct. With the histograms, it had to go in a specific order because of the number line and how numbers sequence. But with this, really we could create any shape we wanted just depending on how we ordered the bins. So that's our bar chart. For pie charts. Pie charts, we start with a circle. And we need some center to the circle. For our pie charts, you want to use the relative frequencies, so our percentages there, and we want to divide up this pie or the circle based on these percentages. Now there is a way of using these percentages and the fact that a circle has 360 degrees, and if we had a nice protractor, we could do this pretty accurately. We're not going to worry about that in our course. We're just going to kind of quickly do one by hand. So with that said, just kind of, meaning like what I do is I try to find percentages that make sense within a circle. So like 56.52%, that's a little more than half of the circle. So I could do is imagine if I drew exactly half, I would just draw a straight line, and that would have 50% over here. So what I might do is that would be 50%, and I'll just add like a little bit on so that's a little larger. So over here is brown eyes with 56.52%. And then from there, maybe I'll go to this 21.74%. It's a little less than 1/4 of the graph, which would be 25%. So this would be 25%. So maybe I'll just shave a little bit off to make it a little smaller. So that would be blue eyes with 21.74%. And then for the rest, green should be smallest, 13 should be larger, but less than that. So maybe something like this. That's close enough. Drawing it by hand, just do the best you can. In a video that I'm going to attach, I'll show you how to do this within Microsoft Excel, because Microsoft Excel can use these exactly, and it will use the actual calculation to divide these up correctly. Like, if I'm being nitpicky about this, these are probably looking too close to the same size for my comfort, but it's the best we can do by hand. So those are our graphs. What we can do is use these graphs to answer questions about probability. So like with numerical data, we answer about center and spread and unusual features. We don't really do that here. We can talk about mode here, like the highest frequencies, like brown would be the mode. But other than that, what we go to is kind of probability and proportions. So for probability notation, it's like function notation, so where we had like f of x, where you had some input for a function and then the function would calculate it. Similar idea here, we describe some event within the parentheses. So an event is just some possible outcome from whatever we're doing. So we have some possible outcome, and this p is saying probability of. So when I see p and then parentheses event, it's just probability of that event. And to calculate it, we create a fraction. It's the number of outcomes for that event out of the total number of outcomes, which is total number of outcomes is coming from our sample space. The sample space contains everything that could possibly come out. So let's try out this notation and calculations. So for what is the probability a student has blue eyes, how I would write this is just P of, so I always say of for those blue. You could do shorter notation, like if you just do B, we can kind of create our own notation here. So probability of blue, using our frequency table, this is actually going to be the same thing as our relative frequency because the number of people who had blue eyes was 5 out of the total number of people, which was 23, and that gave us that 0.2174, which is 21.74%. And something we're going to do in calculating probability is, in the calculation you get a decimal out, and in this course we always want to end with a sentence answer. So we could say the probability a student has blue eyes is, and then when we change it to a sentence, this is where we turn it into the percentage. Because we just talk more often in terms of percentages and probabilities. It's the same thing to say the decimal, but typically within a sentence we'll change it to the percentage form. Probability a student has brown eyes. So that was the 13 out of 23. And 5.2. So we could say there is a 56.52% chance a student has brown eyes. And what's the probability a student doesn't have brown eyes? So probability of not brown eyes. So with that, if we're thinking about our fraction, and in the numerator we're collecting the number of outcomes in this event, so we're thinking about the number of students that don't have brown eyes. So what we could do is just exclude those 13 students. So we have 5 students that have blue eyes, the 2 that have green eyes, and the 3 that have other. So you just combine all of the students that don't have brown eyes out of the 23. And that's going to be, if we change that to a decimal, a 0.4348. So there is a 43.48% chance a student doesn't have brown eyes. And then this last one, what's the probability a student has green or blue eyes? So probability of green or blue. So in the numerator, we want to combine the students that have green or blue. So we take all of the students that have green eyes, which there were 2 of them, plus those 5 students that have blue eyes. So we have these 7 total students that have green or blue out of the 23. So 7 out of 23 will give us a decimal of 0.3043. So that means there is a 30.43% chance a student has green or blue eyes. So, this is how we can organize a single categorical variable, how we can graph it with a bar chart, graph it with a pie chart, and using those frequencies, how we can calculate these probabilities, which another word you might see instead of probability is the word proportion. When we talked about proportions before, you would be calculating this fraction and changing it to a percentage. So those are interchangeable.